Okay, great. Well, once again, thanks, Maddie, and thanks everyone for joining us tonight on our further discussion of ADAS calibrations. Uh, we are in part 5. Today, we're going to be covering best practices. Best practices really is the meat and potatoes of performing ADAS calibrations. So everything that we've done to this point has been an overview of sensors and technology and an introduction to what calibrations are. Now we're going to dive into what it actually takes to perform calibrations. And I'm not talking about what equipment you need. We covered that before, but this is about what you really need to do to perform calibrations accurately. And then in 2 weeks, we'll get into some myths and misconceptions and frequently asked questions, followed by multiple step-by-step demonstrations of different types of calibration equipment. So you can get an idea of what performing a calibration in your shop might look like. So let's go ahead and get started. And as I said, calibration best practices. Well, what is this all about? Well, so many people ask me, how do you know that a calibration has been performed accurately? Will there be a fault code if it's inaccurate? Fact of the matter is, no, there are no fault codes generally for an inaccurate calibration. There are a few vehicle makes and a few systems that can perform can produce fault codes if a sensor or a camera is so far out of calibration that the system just can't function. But quite frankly, the way the OEMs look at this is, you know that the calibration is accurate if you followed all of the instructions to the letter without any shortcuts, and did all your measurements precisely and placed your targets precisely. And after a calibration, you took the vehicle out and did a road test and everything worked. So again, for the most part, the scan tool is not going to tell you if it was accurate or inaccurate. It will tell you if it's successful or unsuccessful. But a successful calibration is not necessarily an accurate calibration. And that's one of the things that we need to discuss. An out of calibration system won't necessarily set a fault code. So the fact that there are no fault code present doesn't mean everything's okay. And a successful calibration just means that the system that you calibrated saw the target that you placed and it accepted it. It's not until we test drive and thoroughly test drive the vehicle and test all of the ADAS systems for how well they react and respond can we determine that, in fact, the systems are operating normally and the calibration was hopefully accurate. So let's go ahead and get into calibration best practices. So what we're going to do is, this presentation is broken up into 6 distinct sections. The calibration skill set. This is what is required of the technician who's going to perform calibrations. This doesn't cover what's required of a service advisor when they're trying to sell calibrations. That's a whole nother topic. The calibration toolkit. This is not the calibration equipment. These are the extra parts and pieces and tools required to be able to perform calibrations accurately and efficiently. And these are items that typically don't come with a calibration system. Then there's consumable items. It's part of the toolkit, but these are items that you're going to be going through and replacing on a regular basis. The calibration environment. This is your shop. This is your service bay where you are going to perform calibrations. And it's one thing to have enough space, but is the space right for performing calibrations? Does it meet the requirements and the criteria for accurately calibrating? And we'll talk about what those environmental settings actually are. Then there's vehicle preconditioning. The vehicle needs to be set up in a very, very specific manner for each calibration performed. And this vehicle preconditioning, the instructions come directly for the OEM, and they change from vehicle to vehicle, from model to model in some cases, Uh, they change from year to year, and they change from system to system. So it's important that when you're looking at these preconditioning instructions, that even though they may look similar from calibration to calibration, they can be very different. So it's important that you read the details and don't just skip the steps that you feel that you don't want to do, because that's what leads to an inaccurate calibration. And then finally, calibration documentation. The documentation is really here to protect you and your shop from any potential future liability. The documentation proves that you followed all the steps of the calibration properly and that you did everything to OEM requirements, that you did everything accurately. And this is the information that you would save electronically or in hard copies for years to come, because you never know when a vehicle may be in a collision and some brilliant lawyer will follow the paper trail. And it really comes down to the last shop that worked on it owns the liability, or especially worked on the ADAS system. So they can track things all the way back. So it's a good idea to keep hard copies of your calibration documentation. Now in the Autel tool, you can store most of this on the tool, but I still highly recommend either electronically backing up the tool occasionally or emailing or printing the documents and storing those additional copies. So calibration skill set. It's not super complicated to perform an ADAS calibration. But first, I want to separate two things. There is the performing an ADAS calibration is really nothing more than taking a scan tool, entering calibration mode, and pressing the button OK to initiate the calibration. The calibration itself is very, very easy and very fast. Generally, somewhere in the 15-second to 1 minute time frame. But the second half is the setup and the preparation, placing the targets, making all of your measurements, ensuring that the targets or calibration fixtures are in exactly the position that the OEM dictates. That's the difficult and time-consuming part. But it's not so difficult from a technician perspective. It's not like a grade A or a level A diagnostic technician needs to be the one to perform calibrations. And let me pause there for a second, because I want to make sure that you understand what I just said. Actually laying out targets for performing a calibration does not require an A-level tech. However, when things go wrong, especially when it comes to wiring and sensor and camera issues, a diagnostic tech will be required to troubleshoot the systems. But just the calibration and the target placement, that does not require a very high level diagnostic tech. It really just comes down to a technician needs to be able to read, understand, in many cases, interpret, and follow detailed instructions without skipping steps. The smallest steps that may seem totally innocuous could just in themselves lead to an inaccurate calibration, many times because the OEM doesn't explain why. There will be things in the preconditioning instructions that just sound silly, and you may want to skip them because they don't sound like they would make a difference. But it's when you research and come to the realization of why you're doing something that it makes all the difference. Now, thankfully, I've had the opportunity over the past couple of years to work one-on-one with a lot of OEM ADAS engineers, and they've given me insight into some of their vehicle preparation instructions, and they've given me the why we are being asked or told to perform certain steps. So we'll keep an eye out for that when we get to that section. Next, this calibration tech needs to be able to make precision measurements with a metric tape measure. You know, a lot of people don't like metric. They just can't get it through their head. They want to perform conversions from metric to US SAE measurements, and that's really not a good idea. only because the slightest miscalculation in a conversion can throw things way off. And all OEs provide all of their measurements, distance to target, target height, the target separation values, they're all provided in metric. Now, our tool provides metric and SAE. However, the inch values are in decimal inches. So where we may be more familiar with 105/8 of an inch, they're going to give it to us as 100.625 of an inch. So then we still have to calculate or convert from decimal to fractions. And that's where we can actually run into some screw ups that will affect our calibration. Metric is easy. It's a base 10 system that really we're working in millimeters. We may also, depending on your tape measure, be looking at centimeters, but that's really about it. So you have a millimeter, 10 millimeters is a centimeter. That's what we need to know. And when you're working with inches, think about this, what we've grown up with all our lives, the measurement system that we have is a base 12 system. A foot is 12 inches, but an inch is now broken down into 30 seconds or 64ths. And there's no equal ways of looking at inches to feet to yards, to miles. Every one is a separate measurement system. In metric, there's one system, and it's all based on increments of 10. Very simple, very straightforward. Next, we need to be able to utilize a plumb bob and a string line. So a plumb bob is probably one of the most ancient measuring and marking devices used by the ancient Egyptians to build the pyramids. It's a way to precisely mark a spot on the ground that is directly below a spot higher up. So in this example, what we would use it for is to precisely mark the position of the emblem on the front of the vehicle and mark that spot on the ground. So it's exactly on the vehicle center line. And then a string line we would use to create long lines. We'd mark a spot at the back of the vehicle and mark a spot at the front of the vehicle and pull a string between those two spots to create the vehicle center line. Now, we can also do that with lasers, and I'll show you some of that in just a bit. Next, we need to be able to create a true 90-degree right triangle on the ground. And anyone who's taken elementary school or high school geometry, we get into the Pythagorean theorem, the 3-4-5 method. If you take a triangle that one leg is, let's say, feet, 3 feet, and the next leg is 4 feet, and you connect the ends of those two legs, they should be 5 feet. So that creates a true 90-degree right triangle. Now, again, depending on the system that we're calibrating and what instructions you're following, we tend to use lasers. Lasers will provide us a true 90-degree right angle, and we could actually use multiple lasers to create multiple 90-degree right angles to form any kind of layout that we need. It does make it easy. We also need to be able to draw on the ground with chalk. Well, most OEMs say to use chalk. The fact of the matter is, we're going to be using grease pencils and painter's tape and markers and things like that. But when I first read that we had to draw on the ground with chalk, I thought, finally, that skill that we learned in kindergarten and preschool is finally going to pay off in our adult lives. But yeah, we do. There's a lot of work to do on your hands and knees, marking spots on the ground, and it's sometimes many spots that you need to keep track of. And generally, the spots are lettered A through Z as you mark them. So just keep that in mind. We need to be able to utilize both spirit levels, also called a bubble level, or laser levels. So levels are going to give us a lot of information about what we're doing. And then we need to be able to make precision adjustments based on everything above. So precision measurements with a tape measure and a plumb bob and creating 90-degree right triangles and using a laser level, then we'll have to very, very precisely be able to move a calibration fixture or a target to be in exactly the position that the OEM dictates. So this is what a technician needs to be able to do. How is a technician going to do all this, and what other tools will they require? So let's talk about this calibration toolkit. This may not be a complete list of everything that's required. I'm coming up with new tools and new accessories that I utilize all the time, that I continually add to my toolkit. I come up with tricks and tips and ways to perform a task 100% accurately, but in less time. And we'll talk about some of those. So let's go through this calibration toolkit. It starts with a metric tape measure. Now, first, this is my metric tape measure of choice. You want an 8-meter tape measure minimum, because there are times when we're going to have to be able to measure at least 6 meters. I prefer, or I like, the Stanley Fat Max, some higher end DeWalt and Milwaukee tape measures, because they have a wider tape, they have a nice curve to them, and they have what's called a good standout. If you take a tape measure and you extend the tape measure while you're only holding the tape measure in your hand, standout is how far you can extend the tape measure before it breaks and falls to the ground. A wider, more highly arced tape measure is better in those conditions, and it helps you perform measurements by yourself without having someone to hold the opposite end of the tape measure for you. So again, this happens to be a dual scale tape measure that's in both metric and SAE. Next, you need a quality plumb bob. This happens to be the one that we include with our calibration kit. It's a retractable plumb bob. But when I say a quality plumb bob, if you look at this one, it's got kind of a long point to it, and the point is very pointy. What makes this a good plumb bob is the point itself is a very small point hovering just over the ground that will allow you to make marks, a cross mark, front to back and side to side, right where that plumb bob is pointing at the ground. Some inexpensive plumb bobs are thicker and they have a very blunt point, which makes it a little bit more difficult to get your hand in there to mark with a marker. Next, a 24-inch, at least 24-inch carpenter square. This is going to become handy when you are trying to make a true right triangle on the ground, when you have to pull a string line 90 degrees from vehicle center line. It can be difficult trying to monitor how those two string lines cross. A carpenter square will help you maintain that true right triangle. Now, there are ways to make your own right triangle. And again, if you remember from a previous slide, the 3-4-5 method, many calibration techs who do dozens of calibrations a day will make a very large folding square. That one leg will be 4 feet long, another 3 feet long, and then the points that connect them will be 5 feet, and it can fold up. This allows you to very quickly do layout on the ground. But the bare minimum, a nice 24-inch carpenter square will come in very handy. Lasers. Most OEMs are still using string lines. But we found that lasers tend to give us a much more precise line. String lines, no matter how tightly you pull them, can still be bumped and tweaked to where they won't be in a perfectly straight line. And many times getting two string lines to cross at precisely 90 degrees can be difficult. This happens to be the Autel 5-line laser, but it does a great job of performing intersecting 90-degree angles as well as a horizontal line. And it even provides a little plumb laser directly underneath the laser itself. So when you make a mark on the ground, you can turn on the plumb laser, set it exactly in the center of your mark, and then you have true 90-degree angles. You can rotate the laser. It's mounted on a bearing, and comes in very handy. Now, again, this comes with our kit, but there are a number of high quality lasers on the market. DeWalt, Milwaukee make really nice, they call them 3-line lasers. They do the same as our 5-line laser. Uh, there are a lot of inexpensive green lasers that you'll find like on Amazon. Many of them are just way too dim to be useful in a shop environment, especially if you have windows or bay doors open. So it's best if you could test the laser you're going to purchase before you purchase one, because a laser could easily be $500 for a quality one. And I will say that the DeWalt 3-line laser and this 5-line are incredibly bright green lasers that are very easy to see over the length of more than a car length. So it makes it very easy for doing layouts. Next is a digital inclinometer. This is it's a digital level, but it only measures level across 2 inches. Digital inclinometers are great for checking the plumb of a radar sensor. So here we're looking specifically at, is the face of the radar sensor exactly 90 degrees to the ground? And you can see here there's a ratchet and a hex wrench attached to the adjustment screw, and you adjust it until it reads whatever value the OEM dictates. Now, this isn't necessarily part of this class, but I want to make a point that this radar sensor is going to be calibrated, but what we're doing in the photo here is not calibrating it. We're doing a mechanical adjustment. A radar sensor needs to be mechanically adjusted before it can be calibrated. And many times, especially if you're dealing with a body shop that is bringing you vehicles for calibration after they've performed collision repairs, many times the radar sensors get hit bending the brackets, and it's not something that is noticed. The bumper or fenders or quarter panels are replaced, and then the vehicle comes to you for calibration, and then the calibration continually fails because the radar sensor isn't properly mechanically adjusted. So just something to consider once you get into radar calibrations. When you start seeing repeat failures on one vehicle, you may want to go back and pull a bumper or a fender, whatever's necessary. Some cases, it's just a grill, and do some measurements on the face of the radar sensor itself. Some OEMs have pretty intricate toolkits for doing just this. Toyota has a really interesting jig that you make by folding paper to create a device from which you'll measure with a plumb bob and a string line to determine if the radar sensor is at the proper angle to the body of the vehicle. Next is a digital angle gauge. This is used in a couple of different ways. Some vehicle manufacturers like Hyundai, Kia will utilize this for setting the angle of a blind spot radar sensor, but this is also useful on the ground when you have to lay out a cross of 2 string lines that do not intersect at 90 degrees. So sometimes you may have to have a 60-degree angle or 45-degree angle. This allows you to get a very fast, accurate digital measurement, and you just line up your strings along this basically digital protractor to ensure that where your string lines are where they're intended to be. And then I'm sure all of you have a accurate tire pressure gauge. You don't want to use an old-fashioned pen type gauge that press it on the tire and the little line sticks out. We need to be a little bit more accurate than that. You could even use a TPMS tool if you want to scan the tire pressure at each sensor. But keep in mind that's only accurate if the vehicle was driven recently. If the vehicle has been sitting for a while, the reading that you get may be the last recorded value. And the tire pressures could have changed with temperature if the vehicle's been sitting in your shop for a while. And of course, along with this, you need some way of inflating tires, something to really consider. One, if you're not in the general repair industry, you're either a glass installer, or if you're doing calibrations mobily, you're taking a portable calibration system out to a location to calibrate someone's vehicle. Ensure you have some type of inflator with you, There's numerous types of tire inflators available today that either are cordless or plug into a cigarette lighter, but it's critical that all the tires are at placard value before we perform a calibration. And then finally, since performing a calibration is very similar to reprogramming or flashing a module, it makes sense that we would also need some type of a vehicle power supply, not a battery charger, just like we do when we're programming through J2534. We need a clean DC power supply, just again to maintain battery voltage. Now, many times this isn't an issue. On some vehicles, Hondas are notorious for having battery problems because they tend to come with a lower capacity battery than most other vehicles. And they have a lot of accessories powered on at the, when the ignition is turned on, the battery tends to drain rather quickly. So in those cases, some type of a power supply is very, very important. And especially on Hondas and Hondas and Acuras, there are certain certain models of cameras that are installed on some Hondas that if the battery voltage drops below 10.5 volts while you're calibrating, it will brick the camera module. It will make it useless. It will have to be replaced, reprogrammed, and then calibrated. So it's a very good practice to maintain battery supply while you're doing a calibration, because there's a long period of time that we're going to have the ignition turned on, especially while going through the setup instructions with the scan tool. Now, it is possible that while you are going through the setup instructions, that you have the car running. That's fine. But when it comes time to actually perform the calibration, unless the OEM indicates otherwise, the ignition should be on and the engine should be off. There are some vehicles that once you get into calibration mode, if you cycle the ignition, so for instance, the engine's running and now we're going to turn it off and turn the ignition back on, you're going to have to back out and start over again. So make sure you understand the vehicle that you're calibrating. You may want to have access to some type of service information system to look up the instructions and the requirements beforehand. ALLDATA, Mitchell, MotoLogic, OEM service information, they all work just fine, but it will give you some extra details that your calibration system instructions may not have. Next, here's some of the consumables in our calibration toolkit. Starts with string line. Now, string lines used a lot of times in the construction industry, especially by masons for laying out level lines for brick or for surveying. String lines come in a variety of different colors. And this really isn't about what color do you prefer. It's about the working environment and what color string line is going to stand out in your work environment. So I found that darker colored string lines tend to work, but it really depends on your floor surface. What color is your floor? Pick a color of string line. There's even white. There's even black that will stand out against your floor. Now, generally, you're going to be pulling string lines if you're using this to create vehicle center line, laying out the right triangles for blind spot calibrations. On Subarus, blind spot calibrations are done by pulling two string lines from very specific points on the vehicle. But Nissans and Infinitis with around view monitoring, certain Nissans and Infinitis with around view monitoring, you actually have to build a box around the vehicle out of string or tape, but it must be straight with nice right triangles. And the around view monitoring cameras in the grille, in the back of the vehicle, and both side view mirrors need to be able to detect the color of the string. In which case I found that like a fluorescent pink, fluorescent orange, fluorescent green tends to get picked up because you're doing this calibration sitting in the driver's seat, actually looking at the around view monitoring screen on the vehicle and adjusting with the scan tool until the lines line up on the screen. So I foresee multiple string lines in your future, let's put it that way, for different purposes, different uses. And You will definitely want to have more than one string line because, again, when it comes to something like a Subaru, you're pulling two separate strings from two separate points. And so you don't want to be cutting off sections of your string over and over again. Having two string lines will allow you to do that and roll them back up for use another day. Next, we need to be able to mark on the ground. If you remember there, I mentioned about drawing on the ground with chalk. Well, what I tend to do is use blue painter's tape and a fine point black Sharpie. You don't want the real broad point. You need to be able to make a mark on the ground or on your painter's tape that is maybe as wide or narrower than the width of your laser beam. So I will generally put a piece of tape down at each location I have to mark a spot using my plumb bob or a laser, and then mark the spot on the ground. And generally you'll have a good 6, 8, 10, 12 pieces of tape on the ground with marking different spots for performing calibrations. So you'll go through tape pretty quickly, especially if you're doing calibrations on a regular basis. Oh, I should have pointed out in the beginning of consumables. The reason I'm even bringing up consumables is because you're going to have to keep buying these over and over again, you may want to think about that shop supplier consumables fee in your calibration costs. Another way to mark on the ground that I found is very helpful, especially if the floors are damp, which many times, in rainy season, some snow on the ground, car gets pulled into the shop, there's going to be water everywhere. Grease pencils will actually mark on the floor even if it's wet. So yeah, that's just another way. You can use grease pencils when it's dry. That's not a problem. They wipe off real easy. And if they don't, a little bit of brake clean and they're gone. But grease pencils are very helpful depending on your calibration environment. And then finally, as far as the consumables, some form of glass cleaner and clean cloths or paper towels, because there's two areas that you're going to need to clean, at least for a forward-facing camera calibration, and that is the windshield in front of the camera and the dash. You don't want anything on the dash that may cause reflections in the windshield. Generally, you don't have to clean the inside of the windshield because the camera is looking through it, unless the owner of the vehicle is a smoker and smoke film has built up on the inside of the windshield in front of the camera. You may be able to see this from outside the vehicle after cleaning the outside of the windshield. You may need to pop the camera out of its bracket and clean that little triangular cutout from the inside to ensure that the camera can see through the windshield. Now, if you're doing that, don't clean the camera lens unless the OEM specifically states that it can be cleaned. Certain camera lenses, if you touch them or try to clean them, the camera needs to be replaced. According to the manufacturer, it can etch the camera lens and it can distort the image. Remember from a previous class, the images picked up by these forward-facing cameras are very, very low resolution. So they can't have any distortion or any cloudiness, anything that's going to affect their vision, because it will dramatically impact the accuracy of the ADAS system. One other thing, just it really comes down to cameras as well. When you're doing an around view monitoring calibration, it is a good idea to go around and clean all 4 cameras on the outside of the vehicle. Those camera lenses, because it's a dual layered lens, can be cleaned because they're exposed to harsh environmental conditions. So keep that in mind. Also, for radar calibrations, if a radar sensor is mounted behind the emblem on the grill, you'll want to make sure that the emblem is clean before performing a calibration. Next, now we start talking about your shop and getting the shop ready for performing calibrations. So this we call the calibration environment. Every OEM says that the floor on which you perform a calibration must be flat and level. Now, different OEMs, a couple of OEMs have specifications. Some OEMs will actually tell you how to measure it. but most OEMs just say flat and level with no allowance given. And as we go through this and we get to vehicle preconditioning, you're going to learn why this is so absolutely critical. We need to have bright, even, controlled lighting. So here's one of the things that I learned from the ADAS engineers. That phrase controlled lighting means you cannot perform camera calibrations outdoors. They must be performed indoors with controlled lighting, which means you can turn them on and off, and in some cases, maybe even have dimmable lights. So if you're setting up an area to perform calibrations, it could be a good idea when you set up multiple rows of lights to either have them dimmable or have multiple switches controlling different rows so you can fine-tune lighting for different vehicles and different conditions. I'm going to show you an example of why that can be important on some vehicles in just a bit. So no windows or stray lighting behind the targets or coming from the side of the targets. It'll cause glare that will throw off the camera. Windows or lighting behind the targets can actually blind the camera and it won't be able to see the target. So the calibration will actually fail. No clutter behind the targets in view of the camera. And what they're really talking about is clutter that could be picked up by the camera as being a target. And keeping in mind that many cameras see in grayscale. So anything that could turn out to look like a black and white or grayscale checkerboard pattern can confuse the camera and cause it to either fail a calibration or calibrate inaccurately. So you may get the message calibration completed successfully, but it may not be accurate because the camera may have calibrated off of something other than your target. It's actually a very common occurrence. And if you're doing radar calibrations, no objects of metallic mass within a specified distance. I was just looking at working with a customer on a 2017 Toyota Camry doing a blind spot calibration and kept failing the calibration. He had everything laid out right, did all his measurements, double checked. And I asked him if he followed all the preconditioning instructions where it tells you how much free and clear space you need. And he says, yes, he did. So I asked him to take a picture of his shop and send it to me. And as soon as I saw the picture, I knew what the problem was. Toyota on this particular vehicle wants 20 feet of free and clear space to the side of the vehicle and 26 feet to the back of the vehicle. And within 10 feet, he had a toolbox and he had a wire welder and some other pieces of equipment. Once we repositioned the vehicle in the shop to ensure that it had the proper free and clear space, the calibration succeeded. So here is one way that I use to check for floor level. Before I get into this, like I said, there are some OEMs like Toyota that will actually tell you how to measure floor level. Toyota in their OEM instructions tells you to take a 9-inch torpedo level and go to different parts of the floor and see if it's level. Now, if anyone's ever done any construction on your house, anything like that, laying tile, and you've used a level, you know that a 9-inch torpedo level can only tell you how level that 9 inches of concrete are that you set it on. It tells you nothing about the floor overall. You could set a 9-inch torpedo level at one end of the vehicle and it's perfectly level, set it at the other end of the vehicle and it's perfectly level, and only have those two areas that you measured be at different levels. Does that make sense? So that's why I don't believe in using a bubble level over a short distance to measure your floor slope, because it is not accurate. So what I do is I take our 5-line laser or whatever laser you're using. Our 5-line laser, the horizontal laser is at 5 inches when measured right at the laser. I will set the 5-line laser at the back of the vehicle, or if I'm doing a shop site survey and we're not actually performing a calibration, I'll set the laser at one end of the bay and I'll go to the other end of the bay, or in this case, I'm going to the calibration fixture and I'm measuring the height of the horizontal level. And you can see here, we're about 1/4 of an inch out of level from front to back. Now, quarter of an inch, 0.25 of an inch, that's not that much, especially when you look at what some OEMs say. Ford says on some calibrations, a half inch over the length of the vehicle. Um, this very likely could be acceptable, but the closer to being exact, the better. So, solution for unlevel floors. This is actually a great solution. Perform calibrations on an alignment lift or any kind of a drive-on lift that can be leveled. No matter how bad your floors are, an alignment lift being level will allow you to perform those calibrations accurately. Now, if you're not in a shop like this to where they've got 25 feet in front of the vehicle to the wall and their alignment machine is on wheels and can be rolled out of the way, if your alignment machine is bolted to the ground directly in front of the alignment lift, you may not have enough space, but you can still back the vehicle onto an alignment lift, whether it's a flush mounted or an above ground, and still get access to a level surface. You don't need to be on the turn plates to perform an ADAS calibration. In this particular setup, the alignment machine can be integrated into an alignment. The calibration fixture can be integrated into the alignment machine. So once you've done a wheel alignment, you can immediately perform a calibration, knowing that the alignment is perfect, the vehicle's level, steering angle sensor is exactly at 0 degrees. It just makes for a very convenient setup. So let's talk about some other less than ideal calibration environments. We may have talked about this one previously, but this particular environment, this was at a training class where we did this on purpose. But as you can see, where the calibration fixture is, there are a bunch of issues. We've got black and white items in the background that can confuse the camera. We have the uprights from the above ground lift that could confuse the camera. Most cameras are going to view from somewhere between 20 degrees and to maybe 44 degrees. And I'll tell you, on this Honda, these uprights were definitely picked up by the camera. So this is not a good environment. Another example of less than an ideal environment, this particular situation, calibrating a 2019 Toyota Camry, the calibration kept failing. And on this Toyota calibration, it's a 3-step or sequential calibration. Right now, the target is in the center position. Then you slide it over to the left side and then slide it over to the right side. And it kept failing on the vehicle right side. And it was because of that window in the background. This is another one where I get to talk to the technician and I ask, did you follow the preconditioning instructions where it explicitly states no windows or clutter in the background? Guarantees me he did. And this is what I see. So covering up the windows allowed the calibration to pass. Here's another one. You can see that there's some windows in the background. This is on a Toyota calibration. They're actually utilizing Toyota's method, and that's holding a 3-foot by 3-foot piece of cardboard behind the target. And in this case, it still failed. Well, after a lot of troubleshooting and building a lot of backdrops out of cardboard to block out all the windows and the lights in the background and not being able to calibrate, the issue here was not the lighting in the background, but the lighting behind the vehicle. Can you see how washed out the target is? It's not black and white. Well, what happened was you can see the windows in the shop, the bay door in front of us, they have the same windows behind us. And the solution was to temporarily cover up those windows so they can perform the calibration. And once they were covered, this is what the target looked like, and the calibration succeeded normally. Another example of a less than ideal calibration environment. This is, again, someone calibrating a Toyota. Toyota very specifically states no open windows in the background. And what do we see? Here they've got this nice facility, nice laid out, flat level floor, neutral colored walls, but windows in the background. Not a good thing. Doesn't mean you've got to remove the windows. Just need something with which you can cover those windows. And here's my all-time favorite. This particular one, I got to give you some background. There is a group online of guys that call themselves the OE only ADAS calibration professionals. They refuse to use anything but OE equipment. They think anyone who uses aftermarket equipment is less than professional, and they just rub it in everybody's nose every chance they get. Well, this was a picture actually taken by one of these OE only calibration technicians, uh, showing that he's doing this calibration. And one, the calibration is being performed outdoors, where this particular OEM very specifically states that calibration cannot be done outdoors. It must be done indoors under controlled conditions with controlled lighting. And two, they very specifically state that it must be performed, the calibration must be performed on a flat level ground. Uh, can anybody see the little bit of slope in the road and how tilted the car is sitting next to the curb? Here, this calibration professional's doing everything wrong and charging customers for it. Don't be one of these guys. So here's another solution to clutter in the background. This shop uses, it's just quite simply a length of metal conduit and some commercially available curtains that they could slide back and forth so they can perform calibrations in their shop and not have to worry about cleaning up everything in the background. One of my customers built this very lightweight board that he mounted to the back of his Autel calibration frame. And this is how he performs his ADAS calibrations. They always have a clean background. They never get any stray lighting or clutter in the background that would confuse the cameras. And it works very well for them. Other solutions, the one on the left, this shop actually built their own roll-around backdrop. And the one on the right, here's a technician that is performing the calibrations in an open carport. And what they did was, with this tent, hang up a black backstop to give them a controlled environment. So the light from the opening, the open door at the backside, isn't going to confuse the calibration. Now, why is controlled lighting so important? Well, here's two examples. First, the image on the left is the calibration target for a Volkswagen, Audi, or Porsche vehicle. This is the way we see this calibration target when we're performing a calibration. On the right is the way the camera on the windshield sees it. So this particular camera is looking for this black and white pattern, but what it perceives as black and white is basically all white with black rectangles and black circles. So when the target is lighted properly, this is what the camera sees, and the calibration will be successful. Now, we changed lighting just a bit. And if you look, the target on the left, this is what we see. And now look at what the camera sees. All of those black spots are what the camera can't accurately detect. And the white spots are what it can see. So if I go back to the first one, keep your eyes fixed on the calibration target. So here's the successful calibration, and there's the failed calibration. Now, when you look at them side by side, it's easy to see that there's some glare on the target. But I will tell you that 99 out of 100 calibration techs would not see this target, if this is all they had to look at, as being improperly lit. It looks pretty darn good, but it's not until the calibration fails. This can cause technicians a lot of hassle trying to get a calibration to pass, to the point that they start second guessing themselves and redoing their measurement and adjusting the target position and the target height, trying to get things to pass. And really, it's just a matter of adjusting shop lighting just a little bit. So vehicle preconditioning. This is what it all comes down to. Every OEM has their specific instructions that they provide in their OEM calibration procedures. We provide those OEM preconditioning instructions in our calibration software. And Every vehicle is a little bit different. On the left, we're going to talk about in general what some of these might be. This is by no means an all-inclusive list, but all fluids need to be to the recommended levels. The gas tank must be at full. The oil and the coolant must be at the proper level. That's what the OEMs say. Now, there is one OEM, Nissan, that says the gas tank needs to be at least 75% full. So 75 to 100% is acceptable. Certain Nissans actually monitor the fuel level sensor in the gas tank. And if the fuel level is below 75%, the calibration will fail. It does not tell you why the calibration fails. It just says it's failed. So you may be trying to play around with a lot of things, and here the instructions very specifically said the gas tank must be full. Many times calibration techs want to skip that step because they fear that the customer won't pay or reimburse them for the gasoline. And if they're working for an insurance company, they feel they won't get reimbursed. However, because this is an OEM requirement, there should never be an issue getting reimbursed for putting gas in the tank before performing your calibrations. In fact, what I recommend is before a vehicle comes to your shop for a calibration, make sure the consumer knows that the gas tank must be filled. And there's going to be something else we need to let them know in just a second. Tire pressure must be adjusted to placard value. Now, placard value does not mean the tire pressure the customer wants to run in the tires. It means the placard value that's programmed into the vehicle, not necessarily the placard that's on the door, on the inside of the door. I'll give you an example. My Chrysler minivan, the placard says 32 PSI. I run my tires at 36 PSI, and I've programmed the vehicle to consider that to be the known good. And it's that 36 PSI that the TPMS system is going to utilize to actually turn on the TPMS indicator telling me I've got a low tire. So if we just go by what the placard on the door is, we may be doing this incorrectly. The reason tire pressure is critical is the tire pressure is basically the foundation of the vehicle, how the vehicle is going to sit, how flat and level the car is going to be sitting on that flat and level surface that we provided back in our calibration environment. So really, really important that we get this accurate, because just a little bit off will make a big difference on camera calibrations as far as the angle at which the camera or radar sensor is pointed. We did a test a while back with a vehicle where we shined a laser pointer or just a dot laser at the emblem on the grill of the vehicle. And then we let 2 PSI out of the front left tire, and that laser position changed by almost a half an inch. Because the emblem dropped, the laser position was now a half an inch high. And if you think of a half an inch at the radar sensor, that's a huge number of degrees, and how far off this calibration would be if we continued to calibrate with the improper tire pressure. The windshield must be clean. Sounds like such a simple thing, and it's not. Every one of these instructions will say that ensure the windshield is clean and the camera is unobstructed. I can't tell you how many times I've gone out to troubleshoot calibrations only to have mud and streaks in front of the camera on the windshield. One time, we were in the middle of a training in Houston, Texas, and we had an issue with the calibration. Looked at the camera through the windshield, and there's a ginormous spider inside the windshield on the camera that had died, and it was obstructing the camera's view. So pay attention to those things when you get into calibration failures. Don't waste a lot of time. Start looking for these particular issues. I will tell you that our tech support line does a lot of calibration troubleshooting for customers, and they tell me that 75% of the calls that they get to the tech support line for calibration failures are fixed by reading the calibration preparation screen on the scan tool. So many people just skip right by it. Make sure the dashboard is clear. I got burned by this one. Here, I'm preaching to you about following the instructions, and I'm doing a calibration on a pickup truck. And we went through the instructions. However, on this particular instruction, it said, make sure the dashboard is clean. And I looked at it and it was clean, wasn't dusty or dirty. Well, calibration failed. Turns out the issue was a gas station receipt, a white receipt that was on the dash that slid forward into the point where the windshield and the dash meet, that caused a reflection back into the camera. Remove the receipt, calibration passed. Make sure all the lights are off and the doors are closed. So any forward-facing lights, headlights, driving lights, parking lights, those have to be off if we're doing a forward-facing camera calibration, because that light will reflect off of the target, cause glare, and could potentially cause a calibration to fail. But also, the lights being on will drain the battery more quickly. And especially when you're new at performing calibrations, it could take 30, 35 minutes to do all the setup. And in that amount of time, with all the accessories on and the vehicle lights on, if the battery is not fully up to snuff, yeah, you could lose power and have to start all over again. But it also says all doors closed. Now, there's two reasons for this. One is the obvious. If a door is open, that's going to change the weight distribution of the vehicle. You open just the driver's door, the vehicle's going to tilt a little bit to the side, and that's going to change the position or the tilt of the camera, which can throw off the calibration. But if you're doing this on a Mazda actually looks to the door sensors to ensure that all the doors, the hood, and the hatch are closed. Another calibration failure that I troubleshot with a collision shop near here was a Mazda CX-5 that would not calibrate. I went out to the calibration center, and the body shop actually, where they're performing the calibration, and I asked if they followed the instructions. So they said they did, and I said, well, let's do this. Let's go through these one at a time. And when I got to the step where it says make sure all the doors are closed, I asked, are all the doors closed? And everybody said yes. And I'm looking at the vehicle, and this is a 3-row vehicle. So it's got the middle row doors. The driver's side back door was missing, and so was the hatch. They were off the vehicle. They're missing. Yet they said that the doors were closed because the door switches were open, indicating to the vehicle that the door and the hatch were open. The calibration failed. Now, technically, they could have taped those buttons shut and the calibration would have passed, but it would not have been accurate because the weight distribution for the vehicle was inaccurate. Connecting a vehicle, well, you know what? I passed right by the most important one. No load in the vehicle. This means nothing that didn't come from the factory with the vehicle is allowed in the vehicle during a calibration. There may be one or two exceptions for dynamic calibrations, but for static calibrations, every OEM wants the vehicle completely unloaded. No extra accessories, no luggage, no groceries. If it's a contractor's van, it can't be loaded down with tools and equipment, with ladders and things on the roof. The calibration cannot be accurate with that type of load in place. So this is the other thing that I strongly suggest you tell your customers before they bring a vehicle in. Make sure the gas tank is full and make sure the vehicle is unloaded. Because again, it is going to throw off the calibration. Front wheels steering straight ahead and the rear wheels steering straight ahead. Well, this is one that is quite often not understood. So front wheels steering straight ahead might sound like you want to just make sure that the wheels are pointing straight ahead. Well, that's not really the case. According to the ADAS engineers, what this line is supposed to read is ensure that the front wheels are pointing straight ahead, the steering wheel is centered, and the steering angle sensor is reading 0.0 degrees. If not, the vehicle needs a wheel alignment. Well, I'm not sure if you know where OEM service information comes from, but unfortunately, it's not the engineers that get to write that information. They write the initial procedures and it goes off to their technical writing group, which may not know anything about cars, and they rewrite it, and I quote, so technicians can understand it. But according to the engineers, they're taking out all the best parts, all the key pieces of information, the why things need to be done. So rear wheels steering straight ahead. A guy I work with makes a joke about this all the time. He thinks it's a mistake because the vehicle doesn't have rear wheel steering. But what this is referring to is the rear thrust angle. What the OEM wants is the rear thrust angle to be as close to 0.0 degrees as is humanly possible. Now, keep in mind that's for a vehicle that is adjustable. When we're talking about, a pickup truck, most pickup trucks, that's not going to be an issue because they're dynamic calibrations, or this won't be an issue or even listed in that OEM's preconditioning instructions. And another one I missed is connect the vehicle battery supply. Again, because the battery could get drained, we need to maintain a stable voltage, because what we are doing is truly programming a module with a new calibration package. So just like we're going to reprogram or flash an ECM on a vehicle, we need to make sure that the camera or radar sensor is able to properly be calibrated, and that includes maintaining a stable voltage. So I know we covered this a little bit in the previous section, but I want to go over this again because it pertains to what we're going to talk about. Every camera has a field of view. The camera sees in a rectangle, just like if you were to take your smartphone and turn on the camera and you hold it up, what you see on the screen is the camera's field of view. Anything outside the field of view, the camera can't see. So when we're talking about the camera's field of view, there are different angles that come into play. Pitch is the tilt of the camera up and down. Yaw is the rotation of the camera side to side. Roll is the rotation of the camera on its center point. And then there is the camera center point. So these are all angles that are measured internally by the camera. And we are trying to, when we are performing a calibration, by following all the preconditioning instructions, get the pitch, yaw, and roll of the camera to within the OEM specifications so we can calibrate accurately. So when we're performing the calibration, what we're doing is by placing the target in front of the vehicle at the correct distance and at the correct height, right where the OEM is expecting it, because we have followed all of the preconditioning instructions and the vehicle is loaded exactly the way it's supposed to be loaded. Full tank of fuel, nothing in the trunk, all the doors closed, no extra luggage or packages in the back seat. The camera center point will be aligned with the center point of our calibration target. So those preconditioning instructions, what the OEM is trying to do is have us get the vehicle set up in a stance that is exactly the same as the vehicle was in at the end of the assembly line when it was first calibrated. Now, we all know that vehicles aren't rolled off the assembly line with a full tank of fuel. Depending on the OEM, they're either going to have 1 gallon or 2 gallons of fuel in the tank. Well, unfortunately, in the repair world, even at a dealership, we really don't have the luxury of draining a fuel tank and adding precisely 1 or 2 gallons of fuel. So what the OEMs have done is they've built in a compensation that will allow us to fill the fuel tank to the full level, to the first click. You don't keep topping it off, full to the first click. And that will put it in the same stance. So the pitch, roll, and yaw of the camera will match the way the vehicle was sitting at the end of the assembly line. That is how we ensure that a calibration will be accurate, by following all of those preconditioning instructions to the letter. If we don't, let's say we chose not to put gas in the tank. And this vehicle, small SUV, comes into our shop. It's got a 16-gallon tank. There's only a quarter of a tank in it. We decide not to put any fuel or even additional weight to simulate fuel in the back of the vehicle. Well, what happens is the vehicle is now going to be pitched up a little bit in the back, which will cause the front end to be pitched down a bit, and the camera will be pointing just a bit low. So basically, the camera is going to be looking at the target like this, and we will be calibrating or teaching the camera that its center point is actually low. So we will be miscalibrating the vehicle by doing this. Now, the way a camera in the real world can determine if it's calibrated properly is while driving down the road under very, very strict conditions. A flat road that's flat for a long distance with no curves, that has clear lane markings or clearly defined road edges that the camera can see. What the camera will do in these rare instances where it meets these kind of road conditions is it looks at the lane lines or the road edges and it follows them to where they disappear on the horizon. And under correct driving conditions, that should be the center point of the camera. The manufacturers call that the vanishing point. However, when we miscalibrate this vehicle, what our camera would end up seeing, because we chose not to put gas in the tank and properly calibrate it, is our camera's looking into the ground. Let's take this from a different perspective. We're calibrating this vehicle, and the OEM says for this car, the target needs to be set at 2 meters as measured from the center of the front wheel. And the camera is looking at the center of the target as indicated by the red line. Now, in this instance, the vehicle is properly configured. It's sitting in the proper stance, the tires, the fuel level, everything is good. And the camera is looking at the center of the target at 2 meters. However, we chose not to put fuel in the tank. So again, the back of our vehicle is going to be pitched up a bit. The camera is going to be angled down. And in our circumstance, that camera is going to be looking a little low on the target. So in this instance, at 2 meters, let's say we have 1 degree of deviation. This is just a generic number that we're playing with here. 1 degree of deviation, which isn't a lot, equates to 1.3 inches at 2 meters. Well, you may think 1.3 inches, that's not a lot. That's not going to change what the camera sees as far as a vehicle or a pedestrian. Now, the problem with that is cameras don't operate at 2 meters. They operate at 100 meters, 200 meters or more. So when our properly set up vehicle is following another vehicle on the road at 100 meters, that camera is looking at a point where it can see that vehicle 100 meters down the road. However, our vehicle that we miscalibrated, the camera's pitched 1 degree, but at 100 meters, that's 66 inches, 5.5 feet that the camera is looking low. This is a real problem, and it is a very common problem. This is something that the Insurance Institute for Highway Safety has well documented, that very slight changes in camera position can vastly negatively impact the operation of a forward-facing camera or forward-facing radar. So in this particular circumstance, our camera is not going to see that vehicle at 100 meters. In fact, our camera is looking into the ground at 65 meters. Any vehicle that is farther away than 65 meters, in this example, our camera would never see. Well, at 70 miles an hour on the highway, if the vehicle is within 65 meters and they ended up, let me back up. 70 miles an hour on the highway, this vehicle's 100 meters in front of us, and they slam on their brakes. Now that vehicle is stopped dead, and we're still driving at 70, 75 miles an hour, and our camera isn't going to be able to see that vehicle until it's within 65 meters, which means we're not going to get a warning for the system. The automatic emergency braking isn't going to engage in time. And this 1 degree of deviation will be the difference between getting into a collision and avoiding a collision. So it makes all the difference in the world. And when it comes to the load that's in a vehicle, if we leave a toolbox on one side of the vehicle, a bunch of groceries, something like that, that could throw off the roll or yaw of the vehicle, the same thing occurs when the other angles of the camera are changed. The camera may be looking to the left or to the right by 5.5 feet if it was off by 1 degree. So these preconditioning instructions are there for a reason, and it's all about allowing us to properly calibrate these systems so they can see 100, 200, 300 meters down the road. So the critical systems like automatic emergency braking and forward collision warning can work properly. I'll tell you something else. In a circumstance like this, where the camera is so far off that it could not properly detect a vehicle for forward collision warning or automatic emergency braking, the lane departure warning will continue to work just fine. So the moral of the story is, if you do a forward-facing camera calibration and you go out for a road test, don't just test lane departure warning. So it's critical that we test all of the ADAS functionality on the vehicle, because that camera does a lot more than just monitor the lane lines. It's playing a huge part in the critical safety systems. Then the last step in our calibration best practices is documentation. And when I say document everything, I mean document everything. I know a lot of shops, when they first get their calibration systems, they do this and more, but then they get lazy over time. And that's when it's going to come back to bite you. So what does document everything mean? It means when the vehicle comes in for calibration, before you touch it, do a pre-scan. The pre-scan is your indication of the condition of the vehicle when it was delivered to you. The pre-scan is your insurance policy with your consumer that the problems that occur on the vehicle or that were existing on the vehicle are not your fault. If we don't do a pre-scan, and let's say that there's a fault code in the camera module and the system can't be calibrated because the camera is faulty, when you tell that to the consumer and you don't have proof, they could very easily say, well, it always worked before until you touched it. This protects you from that. So the pre-scan not only allows you to document all the customer information, your shop information, who worked on the vehicle, but the vehicle information, the VIN, the license plate, the odometer reading, the color of the car, engine size, everything about it, but also document every single module and which ones are without faults and which ones do have faults. And it also allows you on our particular system to take photographs of the vehicle. So if there's any pre-existing physical damage, scratches, dents, dings, broken grill, anything like that, that you can document and attach to this pre-scan so you could show to the customer. We did a brief inspection, we did a pre-scan and took some photographs. We just wanted to let you know we found these things wrong with your vehicle before we worked on it, and just get them to sign off that that damage or those faults did in fact exist before you worked on the vehicle. Steering angle sensor. So all those steps about ensuring the wheels are pointing straight ahead and the rear wheels are steering straight ahead, that's more for thrust angle. But every forward-facing ADAS system, forward-facing radar or forward-facing camera, are based heavily on the steering angle sensor as a main input that signals driver intent. So if the vehicle is being driven and the steering angle sensor is at 0 and it's just very lightly bouncing back and forth between plus or minus 1 or 2 degrees, that indicates to the camera or to the radar that the driver is piloting the vehicle straight down the road. But if the sensor is, let's say, negative 13 degrees, that means the steering wheel is turned slightly, or it interprets it as the steering wheel is turned slightly to the left and the driver is going through a curve. Therefore, the camera is going to ignore something that is 100 yards straight ahead because the driver is indicating that they're turning to the left. But what if they're not turning to the left? What if the steering angle sensor is off, or the vehicle was calibrated with the steering angle sensor off, and we're teaching it that that's what good is? So the camera is always going to be thinking that turning 13 degrees to the left is good, and it will negatively impact the operation of one or more ADAS systems. So what I teach in my calibration trainings is use the scan tool and go to whichever module is going to have steering angle sensor information. It could be the forward-facing camera or forward-facing radar, ABS, vehicle stability control. Get that on the screen and adjust the steering wheel until that reads 0 degrees. Do a screen capture and add that screen capture to your pre-scan, indicating that you properly calibrated the vehicle with the wheels pointing straight ahead, like the OEM indicated it must be done. Very important step. It's also a good idea to do a screen capture or have a hard copy of the vehicle preconditioning instructions. So when someone complains that they don't want to pay for a full tank of gas, you can show that it's required by the OEM. And also show why the vehicle needs to be emptied and the oil needs to be full and things like that. At the end of a calibration, when you get the screen that says the calibration completed successfully, no malfunctions, screen capture it. You want to add that to your post scan. And any calibration related PIDs. What I mean by this is any scan data that pertains to the accuracy of the calibration. I'll give you a very good example of one that often goes overlooked. Subaru, for eyesight, their forward-facing camera calibration is a static calibration. But Subaru also has built in a dynamic calibration that must follow the static, and the scan tool must be connected to complete that dynamic portion. Even though Subaru does not call it a dynamic calibration, they call it an action test, and the scan tool may not refer to it as a dynamic calibration. It still needs to be done. The calibration will never be truly completed unless you perform the static calibration and do the action test, which is the dynamic with the scan tool connected. And there is a PID that you must watch on the scan tool, and it's going to turn to a value of 0F, 1F, 2F, something like that, to indicate that the camera has finished calibrating. Only then is that camera calibration completed. And if you can screen capture that changing PID as well and add it to your post scan, then you have that insurance policy that will protect you from legal liability, ensuring in a court of law, if it comes down to that, that you did everything humanly possible to perform a calibration accurately. After your calibration, after a complete and thorough test drive, then you do your post scan report. And the post scan report, again, you can take photographs. And some of the things that you may want to photograph is a picture of the vehicle to ensure that this is, in fact, the vehicle that we calibrated. One nice thing about the Autel calibration system is every screen capture you make has the vehicle identification, the VIN, year, make, model, all of that information already embedded in the screen capture. Some insurance companies are going to ask you to take a picture of the license plate, even though we've already indicated it on our pre and post scan report. And it's always a good idea to take a picture of your calibration setup, showing that you're using a professional system and you're using the right targets. What I generally do is take one picture on an angle that shows the car and the calibration setup. And then later, after the calibration, I'll attach that to the post-scan report. And then you want to make sure that the customer and the technician both sign and date the report. And that's when you have the legal documentation necessary to protect you and your shop if anything should ever happen further down the road. Well, That's the nuts and bolts of performing an accurate ADAS calibration. Like I said, the actual performance of the calibration is nothing. It's a matter of pressing a button on the scan tool and letting the camera go through its recognition of the target. This is one thing that I don't understand. So many shops pay very, very big fees for these remote calibration companies that have a over the internet scan tool that you connect, and you still have to do all of the setup. You still have to own the targets that you're setting up. You got to take all the time to set them up properly, and yet someone's going to charge $250 to press the button on the scan tool to perform the calibration. There's no reason that you can't be doing this yourself and making that profit for you and for your business. So at this point, if anybody has any questions, you can unmute and ask away, or if you prefer, you could use the chat function.
George, my name is Randy Lusick. Can you hear me?
Yes, Randy, how are you?
Good. So well done. Thank you so much.
Thank you.
I actually just got turned on to this series just today, so I caught a little bit of the first one you guys did, and then I jumped into this one. But this was a great wrap up for anybody looking to try to figure out where they're going with ADAS. This I thought was extremely well done and certainly worth people's time. A couple quick questions. Power supply with the hood closed, the doors closed, the windows closed, I'm assuming. Where are you hooking that thing up? Are you finding room under the hood to
Excellent question. Yes, and thank you for bringing that up because I forgot to mention that one. So many vehicle power supplies have the cables permanently connected to the power supply. And that makes it very difficult to route the positive and negative leads from the bottom of the vehicle up to the battery because they're big and clunky. And usually on newer cars, you don't have holes big enough. I use a power supply from a company called PowerMax. It's a good power supply. It's not like the greatest. It's not the top of the line Clore or Schumacher. But what I like about it is the cables are removable from the power supply.
Oh, wow.
So I could drop them down from the top, connect it to the battery, close the hood, because again, if it's a Mazda, the hood's got to be closed, and then fish them out and connect it to the power supply to perform the calibration.
Excellent. Okay, that I was trying to picture whether we were. I mean, I picture opening hoods a lot today, and even though my power supply is not all that, it's not a big giant roll around. I'd still be hard pressed to stick it under the hood of a lot of cars.
Exactly, and you know, if we're doing reprogramming, Randy, the hood may not hood may not need to be closed. Calibration calibration could be very different.
And then tires and wheels. You know, we just spent some time in my store talking about the effect of not factory size or width or rim offset factory or tires and wheels, and their effect on scrub radius and you know different potential for tire wear and things like that. But now I'm looking at this and thinking, is that era going to end in terms of you know different size tires and wheels, lowering suspensions?
Well, actually, something is going to change. I don't think that era is ever going to end. But 2 years ago, SEMA contacted me, and they wanted me to help them because they have over 800 SEMA partner companies that produce aftermarket accessories that are directly impacted by ADAS. And actually, the number one company that contacted them was Honda, because Honda wanted someone to develop a bike rack that could be mounted to the back of a Honda minivan or a SUV that wouldn't interfere with their blind spot sensors. But yes, so wheels, tires, lift kits, suspension lowering kits, those all directly impact ADAS. But here's what it comes down to. It comes down to the OEM. There are certain OEMs, take in Audi, for instance, they're going to ask you to measure ride height by measuring the wheel arch opening. And there is a range. So let's say we're dealing with an Audi A6 and the normal wheel arch opening is 625 millimeters. Well, Audi will allow anything from 500 to 1,000 millimeters. Oh. And so they give you a variable. So basically what's happening is we're telling it how high the wheel arch opening is from the ground. The camera knows how high the camera is from the wheel arch opening. It does some quick math, and now it calculates its new camera height. Most vehicle manufacturers weren't doing things like that. However, since SEMA started working with OEMs to come up with solutions, General Motors was the first that allowed lift kits on pickup trucks. And unfortunately for General Motors, it's only a 2-inch lift kit, and the camera module needs to be reprogrammed once that lift kit is installed. Well, other manufacturers like Nissan and Ford have actually worked very well with SEMA, and they have created the ability to go into the scan tool and measure the ride height, tell it to the camera. And in a recent vehicle that we did, a 2020 Ford Ranger, we were able to put in a 13-inch lift kit and still have the calibration succeed and be accurate and be within OEM criteria. So as more and more OEMs are going to start getting into this, see, what the OEM doesn't want is if they say you cannot modify the suspension on a vehicle, guess what's going to happen? All the tuner crowd is going to start buying other vehicles if their vehicle can't be modified. So they understand that, and they are rapidly getting with the game and making it so you can calibrate modded vehicles. But it's really only newer vehicles. It doesn't help us with previous vehicles that are already on the road. But anything that's going to change ride height or the angle of the vehicle, you've seen the crazy lift kits that kids are doing today where the back end of the vehicle is squatted and the front end is raised. You can't calibrate an ADAS system on a vehicle like that and expect it to work afterwards.
Thank you again.
You're welcome. Any other
Any
questions?
other questions? Oh, well, I don't see anything in our chat, but if you do have any questions, feel free to send them my way, and I will get them to George. But thanks again, George, and thanks
You're
again
very
everyone
welcome.
for sticking with us.
Thanks for joining us.
Great.
Yeah, have a great night.
Yep, this was part 5 of 7, and we have our next one on the 24th. So see you then at the same time.
Good night.
Good night.